Welcome to the Alpha Training and Consulting's online training program. And today we're going to answer the question, what is the 1.5 sigma shift assumption? And so that's a good question if you're a quality engineer. So here we go. And I drew this out as a 6 sigma process. As you see, I was in a hurry and I didn't get it to proportion or anything else. But just know this, from the average to the spec limit, it's 6 sigmas away, both from the upper spec limit and lower spec limit. This is what you call a 6 sigma process. Again, I apologize. I was in a little hurry when I drew that, so it's not to scale, but you get the point anyway. So what we do is we go and look up 6 sigma in the Z table. There it is, 6.00, 9.9 e to the negative 10th. In other words, it's 0.9 zeros, 0.9 zeros, and the number 99. If you multiply that by a billion, you get 0.99 parts per billion. So a 6 sigma process, according to the Z table, is approximately 1 part per billion. That's for one side of the curve. So you'd have 1 part per billion above the upper spec limit, 1 part per billion below the lower spec limit, for a total approximation of 2 parts per billion on a 6 sigma process, according to the Z table. So the people that first was working on 6 sigma, it was in Motorola. They do a capability study, and they're so happy they made 6 sigma. And so they're giving each other high fives. It's a wonderful thing. That was their goal. And they finally did it with a lot of analytical tools and changing the design of the machines, etc. And then they said, I wonder how close this is to reality. They went to the quality report and boom, oh, it's between 3 and 4 parts per million. This is not a good thing. Our calculation said 2 parts per billion, and in reality it's 3.4 parts per million. Yeah, granted, it's still good, right? But not as good as 2 parts per billion. And not only that, but proportionally speaking, this is a big error. So these engineers, quality engineers, if you will, were not too, they were 6 sigma black belts, is what they were actually. And they decided, what could be wrong here? Why does our calculation not meet reality? And so they brainstormed this problem, and they thought, I think what's happening here, we assume that this average stays still. Okay, that it's nailed to the wall. And if it's nailed to the wall and the average did not move, that's what we would get. But in reality, the average roams, kind of like a cow roams the prairie, okay? It roams around a little bit. And how much does it roam? Well, they decided it must roam about 1.5 sigma. That's what they had to assume, is that this average moves around 1.5 sigmas. But it moves very slow. So if you're doing short-term data, such as a CPK study, it won't pick up on this, because they find this moves rather slow. Okay, and but PPK will pick up on it because it's over a longer period of time, right? So that's the first thing you need to know. So they found that if they took a 1.5 sigma shift assumption, and it was 6 sigma, but if the average moves over here, worst case, 1.5 sigma, it was 6 sigma, but now it's 4.5 sigmas. Then they said, let's go look up 4.5 sigmas with this new assumption. They go over to 4.50. There it is, 3.4 e to the negative 6. I multiply that by a million. It's 3.4 parts per million. There you go, 3.4 parts per million. And that allowed their calculation to shake hands with reality. And so whenever they did capability studies, they assumed the 1.5 sigma shift. Now, if you compare PPK and CPK, you can find out what the actual sigma shift is. That's what I would prefer to do. But sometimes you do need to use the 1.5 sigma assumption, which we will do in a future lecture, by the way. But generally speaking, again, I'd rather look at CPK and PPK and find out what the actual sigma shift is, because there will be a sigma shift. Remember, when things change, it tends to change the average. Change in temperature, change in humidity, change in operators, etc., etc. That's what will move that average around a little bit on you. And of course, we want to minimize that. And so some organizations assume the 1.5 sigma is a constant, but it's an assumption. I'd rather know reality. So that's my opinion on that subject. But this is the 1.5 sigma shift assumption. And again, like I said, you look up 4.5. Well, if you use the 1.5 sigma shift assumption, you do the z calculation, 6, subtract 1.5 from it. If you do the z calculation, it's 4.5, you'd subtract 1.5 from that. That'd be 3, okay? But you're always subtracting 1.5 sigmas from your z statistic and then looking it up. So hopefully that helps you understand the 1.5 sigma shift assumption. All right, hopefully you learned something new there. If you have any questions, please let me know. Remember, if you ever need any ASQ certification preparation training, please keep us in mind. Thank you and have a great day. Goodbye.